Well, hey guys, now today we're going to have a look at the topic on relations and graphs. And I actually came across something that related really well to this the other day. And that was when I was looking to hire a jumping castle, just because I got a little bit bored on the weekend. I thought it might be a good idea to go onto Google and see if I could get a jumping castle for, well, I'd say for me and all my friends, but let's be fair, it was just for me because they're a lot of fun. So this is what I found on Google. I found a whole bunch of information and I realized that there was a bit of a pattern going on. Alright, if you have a look here, you can see that the number of hours that I could hire it for, I've gone along here. So for 1 hour, it's $120. For 2 hours, it's $140. 3 hours, $160, and you get the gist. Alright, so that's the information that I found on Google, and I've actually gone through and written these as coordinates as well, or as ordered pairs. So that is 1, 120, 2, 140, etc. But before we go any further, let's just have a quick discussion, or I'll have a quick chat about what each one of these things are. Now, the number of hours and the cost, they're known as variables because these can change. We know that we can change the number of hours, and of course, when we change the number of hours, the amount of money that we're spending as well will also change. And then we've got another thing which you might not have heard of before, and those are ordered pairs. Now, ordered pairs are also known as coordinates, and you can see here that they are ordered pairs because it's a pair of numbers and they've been ordered. And you can write these actually as a set as well. And how do we know it's a set? Well, it's because we've got these squiggly brackets here. So you can see here I've put all of these ordered pairs into a set, and it's called a set of ordered pairs. Pretty original, hey? Alright, so of course when I've got a set of ordered pairs, I can actually go through and plot these values as well. But of course I need to think about some other things before I just go ahead and plot them. And that is, I need to figure out which one's going to be the independent variable and which one's going to be what we call the dependent variable. Now the independent variable will always go along the x-axis every single time. Alright, so the independent variable goes here. And the independent variable, well, a way of remembering is I like to think of it as being its own boss, alright? It can do whatever it likes, and the dependent variable has to kind of react to whatever the dependent variable is, okay? And yeah, like I said, it always goes along the x-axis. Whereas the dependent variable, well, the dependent variable goes along the y-axis, and I always remember it by thinking, well, it depends on what the independent one does. So the dependent depends on whatever the independent, who is its own boss, does. So if we think about this, well, which one of these two is going to be the independent and which one's going to be the dependent? Because we know that one will change the effect of the other. If we have a think about that for just a couple of seconds, you'll probably realize that the number of hours will affect the cost. The number of hours that we have it for will of course affect the cost. So that is the number of hours will go on the independent variable, and the cost will go on the dependent variable on the y-axis, because the cost will depend on how many hours you want to hire it for, won't it? Alright, so now that we know that, we can actually go through and put some numbers on these axes as well. That is 1 hour, 2 hour, 3 hour, 4 hours, $50, $100, $150, etc. You get the point. So now that I've done that, I can actually go through and plot these points. So I've got 120, so 1 hour, $120 right here. Right here, should I say. 2 hours, $140, so that's going to be here. 3 hours, $160. 4 hours, $180. 5 hours, $200. And 6 hours, $120. Now, if you're pretty clever, you'll probably be able to see that there's a bit of a pattern going on here, and that is they're forming a straight line. Now, of course, when there's something forming a straight line, there'll probably be a rule that we can come up with for as well. That's what actually graphing helps us out with, to see if there is actually a pattern, because sometimes it's not as easy to see it when you just look at this here. Alright, so let's now go on to something else about graphs. So we know what the independent and the dependent variable are. Now we're going to have a look at things called discrete variables and continuous variables. Now discrete variables are represented by single dots, kind of like what we saw before, where we had 1, 120, 2, 140, 3, 160, etc. You can see a whole bunch of discrete dots. Bang, 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 bang. Alright, so just individual dots. Alright, now these discrete variables are things that increase in chunks. Alright, so you can't break it down. So for example, when you're hiring a jumping castle, you'll only be able to hire it for an hour, 2 hours, 3 hours, or maybe an hour and a half, but you can't hire it for really, or they won't let you pay for 1 hour and 17 minutes of it, because they'll go, well, that's just too much work to figure out. So they'll only really let you hire it out for individual hours. And that's why that is a discrete variable, because it goes up 1, 2, 3, 4, 5, etc. You can't have 1.13 hours when hiring a jumping castle. And some other examples are things like names and hire times. So these are all discrete variables. Now, a continuous variable is something that you can actually that can be represented by a continuous line rather than a dot, and that is something that looks like this. Now, these are the types of graphs that we've been dealing with up until now because they are a continuous line, and what they really represent is a million little dots in between here and here, for example. It's even more than a million. It's an infinite amount of dots, so dot 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 dot, dot all the way. So that means we can keep breaking it down. So continuous variables are things that can be broken down further and further and further and further, and you can get closer and closer and closer together. That's continuous because it continues on. And some examples of that are things like time, height, weight, etc. Because you don't just increase by a kilogram, you actually increase gradually by grams or decimals of a gram, and even more. You can break it down even more. And same with your time and your height and things like that. So those are continuous variables. So remember, discrete, individual dots, continuous, continues along as a straight line. You join the dots. So that's all you really need to know about relations and graphs. And of course, hopefully you've enjoyed it as much as this little dog did here on the jumping castle. And that's pretty much the amount of fun that I had as well when I went and got the jumping castle. So thanks for tuning in.